In this video, I'm just going to quickly show you how to use the spreadsheet that I created for analyzing 2x2 contingency tables. So I'm going to use the same data that I've used in the lecture notes and show you what to do. Pretty simple, really. The first thing you do is you put into your table here the names of the levels of your independent and dependent variables. So the independent variable goes on the left hand side here. So in our case it was about job satisfaction. So we have satisfied workers and dissatisfied workers. Okay, and then whoops, back. And then the outcome of interest was above average work performance. So I'll just put above average there. And the other outcome was below average. And then what we do next is just put in our data, our counts. So we had 82 satisfied workers who were above average, and we had 37 satisfied workers who were below average, and we had 31 dissatisfied workers who were above average performers, and 50 dissatisfied workers who were below average performers. And the calculations are now done. So it's told us the phi coefficient, which is interpreted in a similar way to Pearson's correlation coefficient. In fact, this one was invented by Pearson as well, and it's mathematically very closely related. This spreadsheet also calculates the odds ratio, and most importantly it calculates a 95% confidence interval for the odds ratio. So that's really important if your data is from a sample and what you want to do is draw a conclusion about statistical significance for the population from which the sample was taken. So what you're looking for with this confidence interval is you want to see whether or not it includes 1.0. If it includes 1.0, then you can't claim statistical significance, at least at the 95% level. In this case, the 95% confidence interval ranges from 2.0 to 6.5. So 1.0 is not in that range, and so we can claim that with 95% confidence that there's a statistically significant difference between the satisfied and dissatisfied workers in terms of their job performance. We can put in some different numbers, and let's have a look. 40. I'm just making up numbers here. Say 51, something like that. So here you'll see the phi coefficient is small, but it could be large. The key thing here is the confidence interval. The confidence interval now ranges from 0.8 to 2.5, so 1.0 is in that range. So with those numbers we can't make a claim of statistical significance. And that's really all there is to it. Pretty simple. Thanks.